In this next module, I'll just walk you through an example of the use of time-dependent predictors in the literature. Just to get some practice with the idea of using time-dependent predictors, I'm going to show you a study from the literature that was looking at whether or not antidepressant use, women who take antidepressants during pregnancy, does that prevent major episodes of depression. So you can imagine that a woman who has depression may have to wrestle with the question of, should I continue taking my antidepressants during pregnancy? Obviously, we're generally caution women against taking too many drugs during pregnancy because of potential impacts on the fetus. And but if the antidepressants can prevent a major episode of depression, then there might be reason for some women to actually take them. The risks, the benefits would outweigh the risks in that case. So trying to get at that question, there was some authors who had data from a large cohort study. They did an analysis of 778 pregnant women who all had a history of depression. And the predictor of interest here was the use of antidepressants. But you can imagine something like antidepressants is going to change over time. Some women may start or stop taking them during their pregnancy. So we're going to model this as a time-dependent predictor. The outcome here was the time to the first major depressive episode, if a woman had one. You can imagine that one way that the authors could have looked at this data is they could have just said, did the women ever take antidepressants during the study or not? That's going to be a problem, as you'll see, because you can imagine that if you just use the ever-never variable, women who have a major episode of depression during pregnancy may start taking an antidepressant. So you'd have some kind of reverse causality. So it's a really good use of time-dependent predictors here to allow antidepressant use to change over time. Baseline use of antidepressant also may not be a very good measure here because some women may choose to go on antidepressants but may not be on them right at the beginning of the study. And just to get some practice reading statistical method sections, a lot of you are going to have to go on to write these eventually. So I'm just going to show you what they wrote about their predictor from their statistical method section. So we used Cox regression to model risk for a major depressive episode. That's their outcome variable. A major depressive episodes had to last for at least 2 weeks. That's part of the definition of the outcome here. What was the risk period they were looking at? So the risk period that they were looking at was from the second month of pregnancy to 2 months postpartum. So women were followed for those time periods. They were at risk of getting a major episode of depression from 2 months into the pregnancy to 2 months postpartum. Now, interestingly, there was some missing data. So some of the women, they didn't actually know if they had a major depressive episode. Some of them maybe, they lost them or they just didn't have that data. So those missing data were treated as censored for the primary model. They also, just to see what would happen, they did what's called a sensitivity analysis where they also said everybody who we don't really know, we didn't follow them for the entire period of the study. What if all of them went on and actually did have a major depressive episode? How could that affect the results? So they tried treating all of them as having the event rather than being censored just to see how it affected the results. So that's called a sensitivity analysis. You'll see that sometimes when people have missing data. And another interesting point in this method section, for each model, we use the exact method of computation to account for a large number of ties in times to event. So last week we talked about the issue of ties. And in this particular study, they were looking on a monthly basis. They were updating antidepressant use and outcomes every month. So there's only, 9 months, only kind of 9 time points here in this study. So there's an awful lot of ties. A lot of women could have depressive episode in the same month of pregnancy. Large number of ties, therefore they decided to go with the exact method to get it, as precise as possible. And again, the exact method computationally is probably, most computers can handle it, even for 778 women. All right, so then the primary exposure of interest was antidepressant treatment, a time-dependent variable. Okay, so they were allowing this to change over time. We examined models comparing treatment with onset of major depressive episode during the corresponding months. So we also created models for time-lagged antidepressant indicators. So they could just put it in you're either on antidepressants or not in a given month. However, the potential problem with that is, since time isn't measured very precisely here, you can imagine if a woman has a major depressive episode in a given month, she may then, as a result of that, start taking antidepressants. And so if you don't look, if you don't put a time lag in, you may catch some women who are on antidepressants at the time of major depressive episode simply because you haven't measured time finely enough to realize that she got on them after. So they did some time lag models. They said you have to have been on antidepressants at least a month before the event time, or at least 2 months, or at least 3 months to resolve this issue of causal ordering. In the end, they chose a lag of 2 months. So you were only counted as being on antidepressants if you were on them for at least 2 months, just to make sure that there was no reverse causality here. So that was their model. Here is the results from the study. This slide you can't really see too much, so I'm going to zoom in now on the results. So this is from their multivariate Cox regression model. They're presenting the unadjusted and adjusted hazard ratios. They adjusted for a lot of things because this was an observational study. You can imagine there are a lot of potential confounders here. Of course, the variable we care about is this time-dependent antidepressant use. And so when they look at antidepressant use in the unadjusted model, the hazard ratio was 0.85. It's slightly protective, but certainly not statistically significant. In the adjusted model, it's 0.88. So there's really no evidence that being on antidepressants during pregnancy, at least in this data set, it doesn't seem to prevent major episodes of depression. It's trending a little bit in the protective range, but clearly very close to 1 there. So that's the answer from the study, and you would interpret as that being on antidepressants at a given time doesn't seem to prevent against depression in pregnancy. They also looked at they also adjusted for all these other factors. So just to practice interpreting Cox regression results, something that was a pretty good predictor is if you'd had a major depressive episode in the 6 months before pregnancy, it was almost a 3-fold increase in the risk of depression during pregnancy, major depressive episode during pregnancy. After adjustment, that got attenuated, but it was still elevated, an 84% higher rate or risk of having a major depressive episode during pregnancy. There was some elevation in risk if you'd had a larger number of depressive episodes before pregnancy. Looked like if your age at your first depressive episode was below 14, was some elevation of risk, although again that went away in the adjusted model. The races other than white appear to have an elevated risk. And this is one of the few cases where being young seems to be worse and being old seems to be protective. So if you look at age, at least in the unadjusted models, the younger women had a higher risk. Of course, when you adjust for things, that gets attenuated and is closer to 1. Still a trend towards the older women having a little protection there. Education in the adjusted models doesn't look all that interesting. Diabetes looks a little bit interesting, although the confidence intervals are wide. Probably not a lot of women have diabetes in this age group. So that's just some practice in interpreting the results of Cox regression with time-dependent predictors.